Yesterday we started talking about permutations. Permutations, the actual formula for perms, right, is NPR, okay? And you can plug it in and do this. However, when I give you word problems and you're solving for questions, don't worry about actually doing this formula, like plugging this in and whatnot. Just tell me what the NPR is, like what these numbers are, and you can just give me a number. You can just plug it into your calculator and go to town. Unless I ask you to evaluate this, like actually work it out by hand, don't worry about doing that, okay? I don't want you to spend time on that. One pattern that I wanted to bring to life here is that this second number, okay, the second number is what tells you basically how many slots you're filling in. Okay. And the first number is how many basically options you have available, right? So if you have 5, pick 2, that means that you're going to start with 5 and you're going to multiply it by 1 less than 5. That is your answer, okay? If you have 5, pick 5, right? There's 5 slots to fill in. So you're going to start with 5 and basically write it out all the way like that, okay? So 5, 4, 3, 2, 1. So that is a bit of a pattern here. Like if it's 6, pick 1, well, guess what? You're just filling in 1 slot, so it's just 6, right? If it's 100, pick 2, you have 2 slots to fill in. You start with 100, right? And then you go down to 99. So that's a quick pattern there. We also talked about factorials, right? I need you to know what a factorial is. It basically, you start with that number and you keep subtracting from the original until you get down to 1. Okay. Also, let's go to 15 now. That's kind of where I asked you to go. And we started to try different ways. So there's a fundamental counting principle, which is just filling in the blanks. We got our answer. But then this is using the permutation notation, right? So from the 16 balls we have available, we only need 3, right? We're only picking 3 at a time. So yes, you can plug it in like this and solve it. I don't need you to do that. I just need you to, from now on, just go 16 math window, sorry, not math window, alpha window. I need to exit everything. Hold on. Alpha window, pick 7, right? And then just go 16P3 and figure out what that number is. That's all I would need to see if it's a word problem that you're solving for. And there's just one thing happening, right? We're just picking 3 balls at a time. So when I ask you for factorial notation, if I do ask for it, yes, you want to plug it in and reduce it, right? This will be the factorial notation, and you can reduce it even further, but I would be clear about that. Okay? That's normally not what I'm asking you to do on a word problem. Then we had another example here. 6 people running for president and vice president. Okay, so you can tell that there's 2 positions to be filled. It's just 6 times 5, 30. And then factorial notation, we went from the 6 people, pick 2, we got 30 as well. So that's that should be clear. This one here, there were 2 things happening. Okay, make sure you understand this part. There are 12 players and 2 coaches to take pictures. The coaches need to be at the center here, okay? So if you fill in the blank, it's assuming we're taking pictures with all people present, right? We're not just saying there's 12 players, 2 coaches, but we only want to do 6 at a time or anything like that. We're assuming it's all of them, right? So you have to have 12 slots for the players and 2 slots for the coaches, so 14 altogether. So we do the coaches first, 2, 1, okay? There's 2 to fill in that first slot and then just 1 for the second. And then we start with our players, right? 12, it goes to 7 here and then all the way to 1 on the other side. So really, if you have 12 all the way to 1, that's 12 factorial. If you have 2 all the way to 1, right, it's 2 factorial. So another way of having done all of this could have been 12 factorial times 2 factorial. And why times? Because you are multiplying everything after all. So you get this, okay? Watch this part right here, okay? This is what I will from time to time use this because it's maybe a little bit faster. But this is from the 12 players. We actually did pick all 12. You do have 12 pick 12 represented in this scenario. And at the center, from the 2 coaches, you pick 2. Right? If you think about it, this one right here is really 12 factorial. This right here is 2 factorial. Right? So when you multiply these two, you still get the same answer as before. Okay? I just need you to see it. I'm not going to force you to do it one way or the other. But if you look at my answer key from time to time, I do use permutation notation. Okay? Let's go to 16. I did post the key, I know, and if you did the homework, you're good to go. Okay? An artist, so here you have 8 paintings, but you're told you can only pick 5 paintings at a time, right? So it's 8 pick 5. So in this case, you would go 8 pick 5. Question, can you ever have 5 pick 8? Will that ever work? Has anybody tried where the first number is smaller than the second number? Let's investigate. So let's say you're like, oh, is it 5 pick 8? Let's try it. You get 0. Is that a possible answer? No, right? So sometimes that rules out that you can't do it that way. Okay? So you use the fundamental counting principle, which is I have 5 paintings to choose from. For the first painting, I have 8 options, 7, 6, 5, 4. Okay, boom. Or 8 pick 5, boom. Okay. Next, there are 11 candidates that are running for 3 positions. How many possible outcomes are there? There's either 11, 10, 9, or 11 pick 3. You've got it there. Okay, so those are a few things to keep in mind. We're going to do more of this, so don't think that now we're done and we're moving on. But I'm going to add a few. I want to talk about 2 things that you need to be aware of coming up. Okay, so let's go to page 17. Let's stop this video.